Deep in regions afflicted by prolonged, punishing drought, a biological anomaly thrives. The moringa tree survives entirely on the margins of viable agriculture, possessing an aggressive cellular biology that explodes into 3 to 5 meters of vertical growth in a single season. This extreme resilience produces a foliar structure with an incredibly dense nutritional profile. Gram for gram, fresh moringa leaves generate 10 times the vitamin A found in carrots, 17 times the calcium of bovine milk, and 15 times the potassium of bananas. Agronomists and pharmacologists have taken notice. Driven by the massive functional food market and the demand for high-end, clean-label cosmetic extracts, the subsector for refined moringa ingredients is projected to hit a massive $25 billion valuation by 2035, which presents an obvious biological contradiction. If a single drought-resistant tree produces leaves richer than our standard agricultural staples and seeds that generate billions of dollars, we should logically see it growing in every backyard and temperate farm on Earth. But moringa is an aggressive biochemical factory. The exact same metabolic pathways that allow it to survive harsh deserts and pump out dense nutrients also manufacture volatile compounds capable of severe physiological disruption. To understand the utility of the plant, you have to look at the canopy. The leaves contain a profile of essential amino acids, like methionine and isoleucine, that rivals conventional animal meat, making it a critical, life-saving intervention for malnourished populations worldwide. Beyond basic calories, the leaves function as active pharmacological agents. They are highly concentrated with quercetin, a plant pigment that actively blocks the specific cellular pathways in the human body responsible for producing inflammation. Down in the reproductive seed pods, the plant offers a completely different utility for marginalized communities: the ability to safely purify highly turbid, pathogen-contaminated water without modern infrastructure. The scientific mechanism here relies on the residual seed cake left after pressing. The seeds contain water-soluble alpha helical proteins carrying a strong positive charge. When dropped into dirty water, they act like microscopic magnets, aggressively binding to negatively charged dirt and bacteria. Chemists call this flocculation. The neutralized contaminants clump into heavy masses and sink to the bottom, leaving clarified, safe water above. This rapid, low-cost biological efficiency provides a direct, decentralized defense against waterborne illnesses in ecosystems that lack municipal filtration. But the evolutionary overdrive that creates these powerful survival mechanisms does not stop at nutrition and water filtration. It also manufactures lethal biological defenses. The roots and the bark of the moringa tree are definitive hazard zones. Toxicologists classify both anatomical structures as strictly unsafe for unregulated human consumption. The root matrix contains extreme concentrations of spirochene. Spirochene is an endogenous botanical alkaloid that acts as a potent neurotoxin, which, if ingested in sufficient quantities, induces complete nerve paralysis in humans. Even the highly beneficial leaves carry a secondary, invisible risk through severe pharmacokinetic interactions. Pharmacokinetics is the specific study of how a biological body absorbs, distributes, and breaks down foreign substances in drugs. Concentrated moringa leaf extracts can hijack the liver's cytochrome P450 pathways. Cytochrome P450 is a family of essential enzymes in your liver responsible for metabolizing the vast majority of allopathic medications. By altering how these enzymes work, moringa severely disrupts the speed at which the body processes critical, life-saving thyroid and heart medications. Treating the plant as a casual dietary supplement ignores the clinical reality. It is a highly volatile, unstandardized pharmaceutical agent that demands precise handling. Safely extracting the value from this biological machine requires strict, methodical human intervention. We have to actively manage its aggressive biology to survive it. In the field, agronomists rely on severe physical controls. Left alone, the tree exhibits extreme apical dominance, shooting straight up. Farmers must aggressively decapitate the primary trunk and strictly prune the canopy to force lateral growth, preventing the tree from becoming wildly unmanageable. In the kitchen, global culinary traditions utilize intense thermal processing to make the plant safe. Prolonged steaming, blanching, and pressure cooking are mandatory steps to break down the tough cellulose fibers and destroy the heat-sensitive anti-nutrients hiding inside the leaves and immature pods. At the global industrial scale, the focus shifts entirely to lipid extraction. Crushing the mature seeds yields Ben oil, a premium liquid lipid that makes up roughly 36% of the seed's total weight. Ben oil boasts intense oxidative stability and a massive concentration of oleic acid. This highly stable biochemical matrix resists rancidity for over a year without synthetic preservatives, making it a highly lucrative base ingredient for high-end cosmetics and anti-aging serums. Modern agriculture is pushing this even further. New high-yield cultivars like Momax 3 produce enough oil volume to synthesize advanced high-cetane biodiesel. Cetane is simply a chemical measurement of how smoothly and efficiently a fuel ignites inside an engine. At the same time, these massive plantations actively pull and sequester carbon directly from the atmosphere. Moringa is not inherently magical or perfectly safe. Its true value stems from our ability to decode its aggressive biology, respect its toxins, and engineer its structures to systematically solve modern planetary crises.